I don't think it's much of a secret that water is essential to life. In fact, all of the significant biological processes in your body are dependent on water, and are probably occurring inside of water. When you think of the cells in your body, the cytoplasm inside of your cells is mainly water. Even people are made of 60 to 70% water. You can think of people as just clusters of cells, that the majority of which are water. However, it's not just human beings that need water. All life, as we know it, is dependent on water. That's why when we search for signs of life on other planets, we're always looking for signs of water. Perhaps distant and extraterrestrial life can occur on other types of substances, but water is what is essential to life as we know it. To understand why water is so special, we need to start to understand the structure of water and how it interacts with itself. So water, as we've talked about before, is made up of one oxygen atom and two hydrogen atoms. That is why we call it H2O. They're bonded with covalent bonds, and each of these bonds is a pair of electrons that both the oxygen and hydrogen atoms get to pretend like they have. So you have these two pairs, and you might be saying, why are the two hydrogens on this end of the oxygen and not on opposite sides of the oxygen? Well, that's because oxygen also has two lone electron pairs. These things are always repelling each other, and so in reality, if we were looking at 3 dimensions, the oxygen molecules kind of form a tetrahedral shape. So in this image, we can see the two lone pairs of electrons and the two covalent bonds connecting each hydrogen to the much larger oxygen atom. So you can see how it forms this relatively tetrahedral shape. So the key is that the hydrogens are on one end of the molecule, and this is where we're going to see some very, very important and unique properties. Now, one thing to realize is that in chemistry, we draw these electrons and covalent bonds very neatly, but that's not the way that it actually works. Electrons are jumping and buzzing around constantly, like we learned in our Elements and Atoms video. So it's actually much more of a probability of where you might find them. And so instead of thinking of these electrons as though they're definitely in a certain spot, you should think of them as actually more in this approximate area within the vicinity of different atoms. What's interesting about water is oxygen is extremely electronegative. It's one of the most electronegative elements that we know of, and is definitely much more electronegative than hydrogen. So you might be saying, what does it mean to be electronegative? Electronegativity is just a fancy way of saying that it hogs electrons. So it would like to keep electrons for itself. So you could think of what's going on is that the oxygen likes to keep the electrons more on its side over the side that it's bonding with. So even in these covalent bonds, the bonded atoms should be evenly sharing the electrons, but oxygen wants them to spend a little more time on that side. And so they actually do spend more time on that side without the hydrogens than they do with the hydrogens. And you can imagine what this is going to do. This is going to form a partially negative charge at the non-hydrogen end of this structure. It's the Greek letter delta, which is used to signify a partial charge. So this is a partial negative charge because electrons are negative. And then near the hydrogens, since you have a slight deficiency of electrons, it forms a partial positive charge. When you just look at one water molecule, that doesn't seem so interesting, but it becomes really interesting when you look at many water molecules interacting together. On this image, you can see the side that has a partially negative charge on this water molecule is going to be attracted to the side that has a partially positive charge on another water molecule. The attraction between these two is called a hydrogen bond. And this is key to the behavior of water. And we're going to see in future videos all the different ways that hydrogen bonds give water its unique characteristics. Hydrogen bonds are weaker than covalent bonds, but they're strong enough to give water the nice fluid nature it has when we're thinking about normal temperatures and pressures. These circumstances allow these things to be attracted to each other and have some cohesion, but also to break and reform and flow past each other. So you can imagine the thousands and thousands of water molecules bonding together through these hydrogen bonds to create visible amounts of water that we use and require every single day. We will see in future videos how hydrogen bonds are key for water flowing past itself and key for its properties such as its ability to take in heat, which comes from its ability to regulate temperature. This is why lakes freeze over from the surface and are also responsible for evaporative cooling, surface tension, adhesion, and cohesion. And probably most important is that it's hard to rank these things. If you're thinking about biological systems, this polarity that we have in water molecules and in these hydrogen bondings is also key for its ability to be a solvent, which allows polar molecules to become solutes inside of water, and we will see that in future videos. But for now, I thank you all for watching.